My name's Mike Zimmerman. I'm a principal at Allied Consulting Engineering Services in Sudbury, Mass. And Warwick, Rhode Island. You may have noticed it's a pretty unique building. It was built in the 1930s, and the floor to underside of structure at the beams is only 8 foot 4 inches. Plus, next door is the John Hancock building, which is an all-glass building on the northeast corner of this building. So anytime the sun is in the southwest, we get sun on all 4 sides of the building. So the air conditioning loads in here are pretty significant in the afternoon. The structure provided a lot of challenges to the air conditioning equipment, meaning we could have almost no ductwork. The Mitsubishi system jumped up at us as the most appropriate energy efficient system we could put into this building. When Synergy bought this building, it had been empty for 10 or 15 years. 8 of the 11 floors had been empty for 10 or 15 years. And the building was in a horrific state. With the low structure at 8 foot 4 to underside of beams, and no ceilings, no walls, sprinklers here and there, ductwork laying on the ground, windows in need of repair, asbestos on the walls. It was a tough sell. When we walked through the space, just seeing the low ceilings, the oppressiveness of the structure down at you, made it tough to visualize what how a modern office building could be built in this structure. The architect went through several iterations of renderings of various systems and what they might look like in this space. We worked very closely with the architect to structure the HVAC infrastructure, to organize it so that we could minimize the impact into the space. We identified where the major routes and soffits could be and how we could organize that and still maintain 9-foot ceilings. When you looked at the renderings, they looked great, but there's nothing anywhere like being able to walk into the space and seeing it and feeling it. They built this marketing suite just so that a potential tenant could see what could be done, and it was so attractive that somebody wants the space just the way it is.
I was first introduced to this building in summer of 2012 after working with the consultant engineer on many other VRF projects. One of the first challenges we faced was educating the owner on the benefits of VRF. To do that, we started by installing a VRF system in one half of the floor as a marketing suite, which started in August of 2012, which completed soon after, about 6 weeks afterwards, where they were able to take a completed space and show a before and after of what the building used to look like, what the building can look like, and then we're able to use that marketing suite to show it off to the real estate community within Boston.
The owner was very focused on being able to provide a Class A office building in this location. In order to provide a Class A office building, we had to be able to provide a significant amount of zones so that we could have individual office zones, and we had to deal with the challenges of the height of this building, the floor-to-floor height. Well, one system that the architect laid out, that we laid out with the architect, was vertical stacking heat pumps. The problem with the vertical stacking heat pumps is it made the columns really, really big. And when we did the 3D analysis with renderings of what the space would look like with vertical stacking heat pumps, the columns were so big that they became the main feature of the space. When they did the rendering with the VRF system, you couldn't see it. It took the owner about 15 seconds to make the decision, and we were off to the races.
One of the key advantages that Mitsubishi can provide is localized support to the entire design team on a project. One aspect of that is sales engineers that can work with the local consultant engineers, the local architects, to help educate them on how to properly apply VRF systems, but also local service personnel who can work with the contracting community to ensure that they're comfortable installing the VRF systems.
We selected the Mitsubishi system because of the great support that Mitsubishi offers in the New England area. Allied Consulting has done a lot of work on VRF systems and VRV systems with other major manufacturers. And one of the things we liked about Mitsubishi is that we could call a local person to provide local service and local assistance in design and during construction.
A key advantage that we were able to offer was localized support for all members of the design team. As a local sales engineer, I spend the majority of my time working with the local consultant engineers, working with local architects to help them properly design and apply VRF systems. Beyond that, we're able to utilize our local service center, the Boston Training Center, to bring the construction consultant to see an actual system working. Able to see an exposed system, turn it on and off, listen to it run, and see how it runs, played a huge role in helping them accept VRF within their building.
One of the advantages that the VRF system has in this type of office building is that the tenant is very aware of his energy consumption. And most of the tenants were very hip to the fact that VRF systems are very energy efficient. The local real estate community viewed the VRF system as very energy efficient. And it provided a real draw for the owner to bring tenants to this building to see a super efficient building. As a multi-tenant office building, it was very important that the HVAC system that we chose would allow us to be able to apportion the energy consumption to each individual tenant. Of course, the VRF system is able to track the usage of each tenant's fan coil units and making it very simple to apportion energy consumption. Of course, with a multi-tenant building, flexibility is a critically important element, that the HVAC system be able to adapt to their changing space needs. For instance, if a tenant needed to build an office in the corner, modifying the VRF system is really quite a simple task. If they needed to add cooling capacity or heating capacity to a specific space, and adding another fan coil is a pretty simple procedure.
On the roof, there's approximately 400 tons of air source condensers installed on structural steel. The structural steel raises the units up off the ground to prevent snowdrifts from building up and also allows for easy service access. The important things with these units is making sure that technicians can get to the front of the units to access both the piping connections, the electrical connections, and the control boards. One of the main benefits of having the air source condensers on the roof is that they did take up a smaller footprint than the existing cooling tower that was on the roof or many other conventional solutions that would take up roof space. Each floor is served by two 24-ton simultaneous R2 systems that consists of the air source condenser on the roof, which pipes down to floor level where we have two centrally located BC controllers. We were given one vertical chase throughout the center of the building to run all the refrigerant pipework up and down through the floors, where it breaks off into each BC controller. From each BC controller, we were given a horizontal chase where we were able to run the flexible refrigerant line set, which could break off to each individual zone, whether it was a ceiling recessed four-way unit or floor-mounted ductless unit.
The VRF systems are technologically much more advanced than conventional systems used in the United States. If you get an old-timer looking at the refrigeration system, he can't even figure out why it works. Okay? The computer controlling the condensing unit and the fan coil units is analogous to a modern jet pilot whose plane can't be flown without a computer. This machine makes a remarkable step forward in controllability and flexibility. One of the questions we get asked all the time is an air-to-air heat pump an appropriate heat source for a building in New England? Unequivocally, yes. Okay? The Mitsubishi heat pump system is able to provide in the range of 1.5 to 2 times the amount of heat that this building requires. It's a no-brainer and it's not a problem. One
of the great parts about this building is that it's 100% heated and cooled by VRF equipment. In an area where there's a common misconception that heat pumps don't heat, this is a great showcase to prove that variable refrigerant flow solutions are a great solution when you need to provide heat to the building. So far, this project has been a great success with the owner. Such a great success that they've decided to move forward with another similarly sized building, utilizing 100% VRF for heating and cooling, as well as a restaurant and several other properties that they are renovating. Having a showcase property like this has played a huge role in securing other projects within the area as well. Having these projects allows us to show other consultant engineers, other architects, and other building owners that we have done large buildings like this in the past, and that VRF is a good solution for buildings like this.